What you're about to see looks like a magic trick, but really it's one of the most common ways websites get hacked. So today, we're going to pull back the curtain and show you exactly how it's done. And believe it or not, it all starts with a very simple question.
Right? How is this even possible? How can someone get into private data, like, say, your bank balance, just by tweaking a little bit of text in a web address? I mean, it sounds like something that should never work, but you'd be surprised how often it does.
So here's the trick, right in front of you. You see the normal user, admin, makes a request and, yep, gets their correct balance back. But then a hacker sends a nearly identical request. The only thing they change is that username, swapping admin for someone else's email. And boom, just like that, the server coughs up the private balance for a completely different person. The question is, why?
Well, to understand the trick, you first have to understand the web's biggest open secret. At its core, it's all just a conversation. Let's break down who's talking to whom.
See, every single time you visit a website, there are two main players. Your browser, Chrome, Firefox, whatever you use, is the client. It's the one asking for stuff. And on the other end, you've got the website's computer, which we call the server. Its job is to listen for those requests and provide the information. It's just a constant back and forth. So if they're talking, what language are they speaking? Well, they speak a language called HTTP. You can think of it as the official grammar, the set of rules for how the client is supposed to ask for things and how the server is supposed to reply. It's literally the protocol that runs the entire web. And get this is what that language actually looks like. It's not some super complex, encrypted code. It's just plain, readable text. This message right here is basically just saying, hey, get me the available funds for the user admin from the website securebank.com. It really is that simple. Now, this conversation has three really important quirks. First, the client always has to speak first. Second, as we just saw, it's all plain text. But the third one, this is the kicker. It's stateless. This means the server has total amnesia. Every single request you send is treated like a brand new conversation. The server has no memory of who you were a second ago, and that, right there, has huge security implications. So, if the web is just a series of these plain text messages flying back and forth, what if someone could step into the middle of that conversation and start changing the messages? This brings us to a flawed assumption that a lot of web developers make. They design these beautiful websites with buttons and forms, and they assume that's the only way you'll interact with their server. But a hacker knows they don't have to play by those rules. They can skip the website entirely and just write their own HTTP messages from scratch. And how do they do that? They use a special tool called a proxy. The best way to think about it is like a personal post office that sits between your computer and the internet. Every request you send out and every response you get back has to pass through it. And the proxy lets you open up that mail, read it, and even change what it says before you send it along. So here's how that plays out, step by step. First, your browser sends a normal request. But before it gets to the server, the proxy tool intercepts it. The attacker sees that plain text message, makes a tiny little change, and then tells the proxy to forward the new, altered request onto the server. And the server? It has absolutely no idea the message was ever tampered with. Okay, so now we've got all the pieces of the puzzle, right? We understand the conversation is plain text, and we have a tool to get in the middle of it. So let's go back to our original magic trick and reveal exactly how it works. All right, here's that original request again. Your browser sends this out when the admin user clicks the Check Balance button. And I want you to look very closely at that last part. User equals admin. That's the key. So, since we know this is just plain text passing through our proxy, the big question is, what would happen if we just stopped this message in its tracks and swapped out admin for somebody else's username? And that's exactly what the hacker does. Using their proxy tool, they just edit that one little piece of the request before it reaches the server. We're not talking about complex code or breaking heavy-duty encryption. It's literally just changing one word to another. The server gets this modified request, and because it's not programmed to be suspicious, it doesn't double-check. It just says, oh, okay, you want the balance for test@gmail.com? Sure, here you go. And just like that, the magic trick is complete. The server sends back private data that belongs to a totally different person. Now, this kind of security flaw has a proper name. It's called broken access control. And honestly, it's one of the most common and dangerous vulnerabilities out there. It happens when a server confirms who you are, but completely fails to check what you're actually allowed to do or see. So, what's the big takeaway from all of this? What's the lesson? Well, it all comes down to one single, incredibly important principle of web security. And that principle is understanding the huge difference between authentication and authorization. See, authentication is the server asking, "Who are you?" That's you, logging in with a password. But authorization is the next crucial step. Okay, now that I know who you are, what are you allowed to do? Our hacker was authenticated, sure, but the server completely failed to authorize their request to see someone else's money. And at the end of the day, that responsibility lies 100% with the server. It's the server's job to validate everything. It has to make the proper checks. It can't just take the client's word for it, even if that user is successfully logged in. So if you remember one thing from all of this, let it be this. The number one rule of web security is to never, ever blindly trust the client. The server has to act like a deeply skeptical security guard, checking and rechecking every single piece of information it receives. Because as we've just seen, anything coming from the client could be a clever lie. Which leaves us with a final thought. The entire web, everything we do online, is built on this simple, open, text-based conversation. And now that you know just how easily that conversation can be overheard and manipulated, it forces you to ask a really important question. In this digital world, who do you really trust to be listening?